Hello, Kim 121. This is Professor Ship, and I'm going to go over a couple of problems based on stoichiometry, the concept of what is stoichiometry. Stoichi who? So what I'm going to do is show you an example. We're going to walk through it very slowly, and then I'm going to see if you have any questions leading up after this. If you do, please let me know, okay? So I'm going to walk through these problems, and you may see a series of videos because I'm trying to keep them short, sweet, and to the point, okay? So on the screen, I have this one problem that says, how many moles of sodium will react with water to produce 4.0 moles of hydrogen in the following reaction? So here's one of the things that you need to know about a stoichiometry problem. In order to do it, the problem must be balanced, okay? That's the first step. Whenever you have a stoichiometry problem, check to see if the chemical reaction is balanced. In this case, you see that there are coefficients there, so this tells you the problem is balanced, okay? Now, although you see the answer here, that's just to kind of give you a clue of what you are working with in terms of knowing the outcome for your final answer. So let's go ahead and get started with this problem. So it says how many moles of sodium? I am going to block that in. That's going to be my X. That's what I'm looking for. They give you 4.0 moles of hydrogen. Okay? So I rewrote this equation down below, and I'm going to start labeling what I do have. Okay? So let me go ahead and block in the two pieces that they've provided me with. They are looking for the moles of sodium, and they gave me 4.0 moles of hydrogen. Now, whenever you do a stoichiometry problem, my goal is to make you see, or to allow you to see, how there are things you do not need. I do not need this part because they did not talk about water in terms of applying a number to it. We do not need sodium hydroxide's component either. But what we do know is that they gave me 4.0 moles of hydrogen gas. So I'm going to block that in. What I'm looking for are the moles of sodium. Okay? Now, here's what you need to kind of keep in mind here. As you go through this, if I notice that my coefficient initially in the recipe over here was 1, and then it went up to 4, that means everything is going to go up 4 times the amount. So in other words, when I have my initial moles of 1 right here, and it goes up 4 times the amount, that means everything else is going to quadruple as well. So let's work through this problem, and then I'm going to backtrack so I can break down what I just said. Okay? Now, right here, I'm going to simply write X moles of sodium over 2 moles of sodium. And I'm getting that from my part of my reaction here. That's going to equal 4.0 moles of hydrogen over 1 mole, okay, of hydrogen. Now, all you're going to do is cross multiply, okay? So that simply means that I am going to say 4 times 2, or 4.0 rather, times 2. Divide that by what's left over right here, which is a 1. So 4 times 2 is 8.0. Of course, you divide that by the 1, you get 8.0 moles of what you were looking for, which was your X, of sodium. That is your answer. Now, let me break down to you what I just wrote so that way you can understand how this whole process works, okay? When you look at stoichiometry problems, you're going to always have a balanced equation. Sometimes, and if the equation isn't balanced, you must balance it. So let me give you an example, all right? I'm just going to give you a generic example so you can kind of see how all of this plays out. So let me show you right here. Let's say that I have, let me erase that. Hold on, let's see. All right. So let's say that I give you hydrogen plus nitrogen forms together NH3. Okay, I'm going to balance this equation out. Okay. Everything is balanced. Now, what you need to realize is that as you see this particular equation, the numbers that you see in the front, the coefficients, there's an imaginary 1 right there. Okay. There's 3 moles of hydrogen, 1 mole of nitrogen, 2 moles of ammonia. That tells me my mole to mole ratio of each of those items. So that means if I look at the first element here, I see that I have 3 moles of hydrogen. I also see that I have 1 mole of nitrogen. And I see that I have 2 moles of NH3, ammonia. So in other words, the coefficients indicate the amounts of what I'm working with. This also tells me the volume, okay? If I wanted to look at volume, I could say that I have 3 liters of hydrogen, 1 liter of nitrogen, 2 liters of ammonia, okay? So the coefficients that you see at the very beginning of each element or compound indicate either moles or volume. Now, on the flip side of this, if I ask you to give me a mole to mole ratio of, let's say, hydrogen to ammonia, okay? All I'm going to do is look at the coefficient, and that's going to tell me my mole to mole ratio. I have 3 moles of hydrogen to 2 moles of ammonia. So let's say hypothetically that I wanted to ask you, all right, well, what's the mole to mole ratio of hydrogen to, let's say, nitrogen? Look at the coefficients and you would say, oh, that's 3 to 1. Okay? Plain and simple. So in the case of me doing the problem that I showed you previously that was written in red, I could then take this problem another step further, where I could say, well, what if I wanted to know how to solve a problem using these moles and coefficients? So let me give you an example. If I have hydrogen plus nitrogen producing NH3, okay? Again, let me balance it out right here. If I say how many, well, let me go back for a second, okay? If I tell you that in your problem, you are given, let's say in your original recipe, because really and truly, ladies and gentlemen, stoichiometry is like cooking for a chemist. It tells me how much I have originally in my original recipe, which is what those coefficients are, versus what I want to know in the end. So my initial concept tells me that I have 3 moles of hydrogen, 1 mole of nitrogen, and 2 moles of NH3. So let's say that I wanted to change my recipe to, let's say, having 6 moles of hydrogen. Now, if my original recipe calls for 3, but all of a sudden I decide to have 6 of them, I know that I increase this by a factor of 2. In other words, 6 divided by 3 gives me 2. So that tells me that my hydrogen factor doubled. Okay, let me say that again. If my original recipe calls for 3 moles and all of a sudden I increased it to 6, that means it doubled. Okay, double means twice, 2. Okay, so guess what? If my moles of hydrogen double, what's going to happen to my moles of nitrogen? If it was originally a 1 right here, what's 2 times 1? 2. So that means my moles of nitrogen goes up as well. Let's look at ammonia. If my original recipe calls for 2, but all of a sudden it doubles, how does 2 double? It becomes 4. Okay? It's that simple. Let me give you another example in terms of food. If I know that it takes 2 pieces of meat Okay, I'm sorry. 1 piece of meat plus 2 pieces of bread. Let me go back and erase that. Okay, let me start it over. See, I'm a vegetarian, so I kind of threw that problem off just a little bit. So let me go back and rephrase this concept, okay? So let's say that I have 2 pieces of bread plus 1 piece of vegetarian meat, okay? Just for the sake of me doing this problem. All right, this is going to yield 1 sandwich. Well, let's say that I want to make 2 sandwiches. How many pieces of bread am I going to have if my sandwich number increases? Okay, so let's work this problem out. So if I know that I want to have 2 sandwiches now, how many pieces of bread am I going to have? If my original recipe called for 1 sandwich and I doubled it, what is going to happen over here? Everything is going to double as well. So what's 2 times 2? 4. So that I'm going to have 4 pieces of bread and 2 pieces of meat. Meatless sandwiches, meat that is. So in other words, if one thing doubles, everything else has to double. If one thing triples, everything else has to triple. So, students, stay tuned for the next video coming up. I'm going to expand on doing another type of stoichiometry problem, and it's going to be similar, but a little twist to it, okay? So stay tuned.